Hello friends, in this video I will start analytical geometry, that is also known as coordinate geometry. So first of all I will explain the concept related to coordinate of a point, and then after I will move on to different concept related to coordinate geometry or analytical geometry. So let's start. So first, as you can see here, this is the plane. Okay, so that's you already know that plane is nothing but two dimension. Means here if there is two dimension, then that is known as plane. So here length and breadth, so two, so it means one you can see from top to bottom and then one from left to right. Okay, so here if we have to represent any point, okay, in the plane, then that we can represent by using coordinates. Okay, for example, here a point A is there, so that point A can be represented by coordinate 3 comma 2. So the question it is, what is this coordinate? Okay, coordinate, it is the combination of what horizontal, or you can say the distance along the x-axis, okay, and distance along y-axis. If we write those two inside parenthesis and in between those two if we put comma, then that is known as coordinate. Okay, so for this, here 3 representing the distance OM, okay, and 2 is representing AM, means AM is vertical distance of this point from x-axis. Okay, so this horizontal distance, or you can say perpendicular distance of this point M, okay, or you can say the perpendicular distance of this point A from y-axis, that is known as abscissa. Okay, so that's here it is represented here. Abscissa means the first coordinate is known as abscissa and the second coordinate is known as ordinate. Okay, so what is abscissa? The horizontal distance from the origin, and ordinate means the vertical distance from the origin. Okay, so now you can see, so you got the ordinate and the abscissa. So the point where horizontal axis x complement and vertical axis y complement, the point where these two axes cross each other, that is origin, here represented by O. Okay, the same thing here written in the statement. Now next here we have to see that the relation between abscissa, ordinate and radius vector. Okay, now here it is a term given, radius vector. So now this vector, now you can see the distance from the origin to the point, okay, in the plane, that distance is known as radius vector. Okay, so that's why here it is written radius vector of point A, that is represented by R. Okay, and the horizontal distance we represent by X and the vertical distance we represent by Y. So now here you can see the relation between abscissa, ordinate and radius vector. So in that figure, as you can see here, in this figure, OAM is a right angle triangle, and according to Pythagoras theorem or Pythagorean rule, so hypotenuse square equals perpendicular square plus base square. Okay, so that's what here it is written by Pythagorean rule. We can write down OA, that is the hypotenuse, OM, that is base square, plus AM, that is perpendicular square. So we can write down at the place of OA R, and at the place of OM we can write down X, and at the place of AM we can write down Y. So hence we can get R equals square root of X square plus Y square. So this is the way we can find out the radius vector of point A. Okay, now so in this example, how we can find out that radius vector? So that's I will show you. So now you can see here, I will show you. So since there A is, what is there A? A is 3 comma 2. Okay, so R we can write down square root of x square. So x square means 3 square plus 2 square. So here we can write down 9 plus 4 equals a square root of 13. Okay, now next here it is the length of the line. Now next here is the length of the line joining points P and Q. Okay, so here 2 points P and Q given. So the coordinates of P here given x1 comma y1, and the coordinate of Q given x2 comma y2. Okay, and here perpendicular is drawn from Q to Q on the x-axis, that is Qm, and from P it is Pn, perpendicular. Now you can see here PS. So PS this distance, it is equals nm. PS is equal nm. Okay, and say nm equals, we can write down om minus on. Okay, so here om is x2, because I already explained that the first coordinate represent the horizontal distance along x-axis. So in case of Q, so x2 is the horizontal distance om, so that's why written x2 here minus on. So on is the horizontal distance. Okay, so P here, n for this, and horizontal distance is on. So for this x, here it is x1, so x2 minus x1 we can write down. And in the same way for QS, this is for vertical or along y-axis. So here m here given mq, qs, here qs, this one we have to find out. We have to find out the sides of this right angle triangle. So ps we got from here, and now the second side here perpendicular, it is qs. So how we can get that qs? So qs, it is the vertical distance. So here we can write down qm minus sm. So qm minus ms, we will get qs. Okay, so at the place of mq, write down as it is, minus at the place of ms. So since ms equals to pn, ms and pn both are equal, so we can write down pn. Okay, so mq is what? The vertical means y2. Why? Because vertical distance is represented by y, so here y2, and pn, the vertical distance represented by y, here it is y1, so y2 minus y1. Okay, so that we got. And now by using Pythagorean rule, so as you can see, since PQS is a right angle triangle, so by Pythagoras rule we can write down hypotenuse square equals base square plus perpendicular square. So base we already got PS as x2 minus x1, so a square, plus, and QS we got y2 minus y1, so square here. So if we remove this square, so we will get the square root of this. Okay, so this is the way we can find out the length of the line joining 2 points. Okay, in this way we can find out the length of line. Here you can see, in this way we can find out the length of line joining points P and Q. So this is PQ, which we got here. Now on that concept. One question here it is given. Find the length of the line joining points. Here coordinates of the points given. Okay, so we have to find out the length. So length, here the formula, here it is square root of x2 minus x1 square plus y2 minus y1 square. So simply put the value of x2 x1, y2 y1. So here x2, so x2 here it is 3. So the first coordinate of this here it is the first element of the second coordinate. So here it is 3, so 3 written minus x1 here it is 1, so write 1, y2, so second so 2 minus y1 here it is 1, so simply put, so you will get here 2, 3 minus 1 2, so 2 square you will get 4, and 2 minus 1 1 square 1, so 4 plus 1 5, so square root 5. Okay, now next, the next topic here, it is coordinate. Now you can see here coordinates of the midpoint of the line joining the points P and Q. So 2 points given, P and Q given, so we have to find out the coordinate of the midpoint, that is R. So we have to find out the coordinate of the midpoint R. Okay, because the coordinates of P and Q already given, so we have to find out the coordinate of the midpoint R. So how we can find out? So now you see the method. OS equals, we can write an ON plus NS. If we add ON and NS, then we will get OS. Okay, and also we can write OS equals OM minus MS. If we subtract OM and MS, then we will get OS. Okay, so here two things. Okay, this is not equation, this is not equation 1, this is equation 1. Okay, so then after you can see here, so since NS equals to MS, why? Because since R is the midpoint of PQ, so S will also be the midpoint of NM. Okay, so at the place of MS we can write on NS, so NS I have written here, and the reason written I have written since NS equals MS, as S is the midpoint of NM. Okay, so now if we add these two equations, so we will get in the left hand side 2OS equals ON plus OM. So ON means this NS plus NS minus NS will cancel each other, so remaining term will be here ON plus OM. Okay, so here we can write like this, and then simply bring these two to the right hand side, so it will go to the denominator, so OS will be equals ON plus OM divided by 2. Okay, so now we can write down at the place of OS as X and ON is X1. How? ON is X1. Now you can see here in this figure, I think it is clear in this figure. ON here is horizontal distance, so horizontal distance is X1, and OM is the horizontal distance, so here it is X2. So we can write down X1 plus X2, so that's why here it is shown X1 plus X2. Now it is clear, so X1 plus X2. In the same way, just the way we did it here, what I did here, I had drawn the vertical line. Okay, I have drawn perpendicular from this line on the x-axis. If I draw perpendicular from these 3 points on the y-axis, okay, then in the same way, by using similar process, I can get this. I can get RSY equals y1 plus y2 divided by 2. Same process, just the way, similar process. If I do, then I will get this result. Okay, so hence I can write down the coordinate of the midpoint r is here given x comma y will be equals x1 plus x2 divided by 2 comma y1 plus y2 divided by 2. Okay, on the basis of this concept, one question here it is given. So now see, so find the coordinates of the midpoint of the line joining these two okay, these 2 points are given, so we have to find out the coordinates of the midpoint, okay, of the line joining these 2 points. So by using the formula here, simply x1 plus x2 divided by 2 will give the x coordinate, and y1 plus y2 divided by 2 will give the y coordinate. Okay, simply put, so this is, now you can see, this is x1, this is y1, this is x2, this is y2. Now simply you can put the formulas, the values. Okay, x1 plus x2, so minus 3 plus 7 divided by 2, we will get this 2. And in the same way, y1 plus y2, so y1 here 4 and plus minus 7, so 4 plus minus 7 divided by 2, so we will get minus 3 by 2. Okay, hence we got the value of x and y, so hence we got the coordinates of the midpoint of the line joining these 2 points. Okay, so thank you all for watching. Please like, subscribe, share and press the bell icon for more related videos. Thank you.